Welcome back. Bitcoin script. So in the previous lecture, I kind of oversimplified how a Bitcoin transaction looks like. In reality, it's not that simple. You have inputs and outputs, but in order to validate a transaction, you're really evaluating a program. And this program is a stack-based program, which is based on the script language. So here, this program evaluates to true if the Bitcoin transaction is valid. The Bitcoin script language supports quite a few opcodes, and the execution time of a script program is really critical to prevent denial of service attacks. So we don't want to compute too much here. It has to be quite simple. But this programming language is really this is a genius move from Satoshi, in a sense, to allow for more flexible transaction types than just a simple transfer. So to give you some example script here, we have a signature, which is a constant. We have a public key, which also is a constant, and then we have an opcode, and the opcode is called check SIG. So what do you think is this opcode doing, check SIG? Think for a second. So check SIG means basically check signature. So once you have a signature here in the public key, these are constants. They are pushed onto the stack by the execution engine of this stack-based programming language. And once you have them on the stack, you can execute the operation, which executes on the stack, and this verifies whether the signature matches the public key. So whether the signature is a valid signature under that public key. So now let's look at the Bitcoin transaction, how it's actually executed. So we can see here we have a transaction that sent some coins to Alice. Remember, this is the example from previously where we have a change address and we're sending change back to Alice. So in reality, what happens is that we're taking this particular input, we're taking this particular output, and then we're merging them down here together. And this is the whole, like basically what you see here at the bottom, that's the whole program that's happening. And let's execute this now together. So the first step is that we have to push the constants on the stack. So the stack is just like a pile, you can think of it, where you pile up the different constants that you then want to use once you execute an opcode. So opdup means to duplicate the last value on the stack. So we have currently pubkey and SIG on the stack, so then we will move towards pubkey, SIG type of stack, as you can see here, right? So we executed opdup, and now we have one more element on the stack. So the next opcode is ophash 160, which means we're gonna have to take the hash of the public key, which is on the top of the stack. So now we have a pub key on top of the pub key hash on top of the stack, right? We replaced pub key with one pub key hash here. Now you might ask, why do we have twice here the pub key hash now? Well, think about it for a while, and we will be discussing it in a few seconds. Let me resolve the puzzle. So here at the bottom we have a public key hash, right? So this is another constant that's pushed onto the stack, and I just jumped this particular step just to have enough space on the slide. But for those of you who were attentive, I think you saw that this is a particular constant here that we put onto the stack. Great. Now we're gonna execute op equal verifier. That's the next opcode. And this basically means we're gonna verify the equality of these last two elements on the stack. So then once they're equal, they're removed from the stack, and the last element is an object SIG, which means we're gonna check the signature, and if this signature is correct, then the program returns true. If like a Bitcoin transaction evaluation returns true, the consensus is that this is a valid Bitcoin transaction. So the beauty of this particular script hash language, script language, is that we can perform quite a few transaction types. You can also invent new transaction types if you want to, and propose them as a Bitcoin improvement proposal. Just to give you a few examples here, we won't go very much into the details, but you have, for example, pay to public key hash. So if you want to pay to public key hash, then the redeemer needs a public key and the signature. You can pay to a script hash. So instead of paying to a public key hash like an address, you can pay to a script hash. You can perform a multi-signature transactions where you require m out of n signatures to send coins, which is quite interesting for large wallets, for example. You can increase your security by having multiple signatures required to perform a transfer. So these are just a few examples of how to extend or how to use more sophisticated Bitcoin transactions. Thank you very much for listening, and see you in the next lecture.